In this problem, we want to find out what is the current passing to this 6 ohms and what's the current passing to this 12 ohms. That's the problem. Let's have a look at the problem. You can see there is a battery connected, which is a 30-volt battery. From the positive plate of the battery, a current starts. Let that current is I. That I will go. Entire I will go through this 4 ohms. After reaching this junction, as there are two resistors, this I is divided across these two. How much it is, we have to find out. Let me call them as I1 and I2. That I1 and I2 after reaching this junction will again combine and become an I. It will travel back through this 2 ohms and then to the negative plate of the battery, and it will be keep on happening. This is how the current is distributed. So if you look little carefully here, across this 6 ohms and 12 ohms, current is distributed. Whenever current is distributed, that's a parallel combination. So you can say 6 ohms is in parallel with 12 ohms. So how can I find out the effective resistance of R parallel? We have done this so many times. We have a formula, R1 R2 by R1 plus R2. R1 is 6, R2 is 12, 6 plus 12. So the value is 6 into 12 by 6 plus 12 is 18. 6 3s as 18. 3 4s are 12. So the effective resistance of 6 and 12 is equal to 4. So if you draw a equivalent circuit of the above, if you look for an equivalent circuit, I can draw that as 4 ohms instead of 6 and 12. Again 4 ohms. Here it comes. There is a 2 ohms. And then there is a battery of 30 volts. This is how the equivalent circuit is. So if you look at the current distribution again, from 30 volts current I starts, entire current I will go through this 4 ohms. The same entire current will go through this 4 ohms, which is a combination of these two resistors. So that's not a single resistor, it's actually a combination of these two resistors. That 6 and 12 is equal to having an effective resistance of 4 ohms as shown here. And that will again pass through this 2 ohms and then go to the negative plate of the battery. As the same current is passing across all of them, we can say all the resistors are in series. So we know the formula. R series is R1 plus R2 plus R3. R1 is 4, R2 is 4, R3 is 2. So 4 plus 4 plus 2, that is 10 ohms. The total voltage of the circuit is 30 volts. Total resistance is 10 ohms. I can use the Ohm's law. V equal to IR. So 30 equal to I, we don't know. R is 10. So the current in the circuit is 30 by 10. That is 3 amperes. So now I know at least the total current in the circuit is 33 amperes. So that 3 amperes will go here. But that 3 amperes is get distributed here. That's how we have to find out. How does that 3 amperes is distributed here? Because they two are in parallel. So if I look for the circuit, this is what our problem is now. There is a 6 ohms. There is a 12 ohms. The current that is coming to this branch is 3 amperes. That 3 amperes is distributed as I1 and I2. How much is values of this I1 and I2? That's what our question is actually. If you look back our question, that's how we have to phrase our question. Now, these two are in parallel. Whenever they are in parallel, voltage is same. V is same. We know the formula, V equal to IR, which is same. So I is inversely proportional to R because V is constant. So I can say I1 by I2 equal to R2 by R1. R2 is 12, R1 is 6. So 12 by 6, that is 2:1. So the total current shall be total current of 3 amperes shall be divided in the ratio of 2:1. So 3 amperes divided in the ratio of 2:1, simply this is 2 amperes I1, this is 1 ampere. This 2 and 1 will combine together, that will become 3 amperes. That's how I can find out resistance across 6 ohms is 2 amperes, whereas resistance across 12 ohms is 1 ampere. So, but anyway, if you want me to solve this, how do you get this ratio? Let me please find out in a formal way. We can do that. That's also a simple thing. I will solve the problem in another alternate way. For the last step, there is an alternate way. What is that last step is? This is 6 ohms. This is 12 ohms. How the current is distributed? What is the value of the I1? What's the value of the I2? That's what we are supposed to find out in this problem. That can be solved quite easily the other way, using the same concept. They are in parallel. V is same, that is equal to IR as per the Ohm's law. As I have written in the previous case also, I is inversely proportional to R. I1 by I2 is equal to reciprocal R2 by R1. Let me add a +1 to this equation on both the sides. Then it will become I1 plus I2 by I2, R2 plus R1 by R1. We know I1 plus I2 is the total I. So I by I2 equal to R2 plus R1 by R1. Total I is 3 amperes. I2 we have to find out. R2 is 12. R1 is 6 by 6. So 3 by I2 is equal to, here 12 plus 6, 18 by 6. 6 3s are 18, 3 and 3 will cancel. I'll get I2 as 1 ampere. As I2 as 1 ampere, and I1 plus I2 is 3 amperes. I1 plus 1 is 3. That implies I1 is equal to 2 amperes. I will get back to the same answer that I have found here. 2:1. So the currents are distributed as 2 and 1 amperes. Total 3 amperes is. So in any of the way, you can solve this problem, right? Thank you.